This video is over writing and graphing equations and inequalities. It is a review for your test next week on either Wednesday or Thursday, whenever you choose to take it. And it really helps us make the connection between scenarios, equations, and graphs, and determining what relationships and things we can find out from those three representations. So let's go ahead and look at what we're going to be doing today. We are going to be looking at highlighting and defining variables, setting up equations, solving equations, and graphing the equations. And I say graph a little loosely. We're actually going to be sketching them and looking at some important points in there as well. This link right here is going to take you to the same link you're going to see on the milestone when it asks for graphing questions. This is a link to Desmos that the EOC test will use this year. So we're getting a kind of a head start on what that's going to look like. It looks very similar to what we've been using already in class. Every functionality we've used so far is the same you'll see there. Okay, so we're going to do the first question together, and then I'll let y'all move on your own. Just remember that this is a review for our test, and just to get some practice looking at the different representations. So the first few problems, you're going to use slope-intercept form. And when we use slope-intercept form, you want to use that when you're given a rate of change or a slope, and a starting point, which we can call the initial value or the y-intercept in this case. And remember that slope-intercept form is that y equals mx plus b, something we've been working with for quite a while. Once we read the scenario, let's go ahead and do that. It says you and your friends plan to attend the county fair this weekend. The admission to the fair is $5. So we're already thinking, okay, no matter what, I got to pay $5. That's my starting point. And the cost per ride is 50 cents. I see that word in there, per, so that's going to tell me my rate of change. My rate of change is right there. We've also got the variable, so the cost per ride is 50 cents, and y is the amount of money spent at the fair, while x is the number of rides. So we know that our x is our independent variable, and our y is our dependent variable. The money we have to spend depends on how many rides we have to ride. So when we write our equation, since we're writing in slope-intercept form, we're going to have y, our total amount of money spent, is equal to the 50 cents per ride. And we put the x next to the 50 cents since each ride is 50 cents, plus the $5 that we pay to get in. If you also write y equals 5 plus 0.50x, that is the same exact thing. It doesn't matter. Let's use our new equation to solve our first question. It says, if your parents give you $20, how many rides can you go on? So since we know that $20 is a cost or is an amount of money that we spend, we know that 20 is going to represent y in our equation. So taking our equation of y equals 0.50x plus 5, I'm going to replace that y with a 20. We're basically doing substitution. So we have 0.50x plus 5. From here, I subtract 5 on both sides, and I'm going to get 15 equals 0.50x. And I divide by a half on each side, and I get 30. Now, if you're thinking I should have gotten 7.5, literally what 15 divided by 0.5 is how many halves are in 15. There are 30 half pieces in 15. So 30, so basically what that means is you can ride 30 rides. You can ride 30, there we go, rides. Too much R's in that sentence. You can ride 30 rides. All right, perfect. Now, here's the Desmos part. So again, to get access to Desmos, you can always just go to desmos.com/graphing, or you could scan this link so you get an idea of what the milestone is going to look like. So go ahead and scan that, and it should give you something that looks like this on your screen, if mine feels like changing. Here it is. Okay. You should get something that looks like this. So again, notice that this is pretty much the same thing that we've been looking at. So let's go ahead and type in our equation. Okay. So we have y equals 0.5x plus 5. Okay. Y equals 0.5x plus 5. That's what we just graphed. And with your fingers, you can kind of zoom in a little bit because I do not want to look at any other quadrant except for the first quadrant. Let's think about that. I can't have negative money and I can't ride negative rides. So the first quadrant is really the only thing that's applicable to me. So in our assignment, let's go back to that for a moment. Let's go ahead and draw our X and Y axis. All right, here's our X and Y axis. And we got to label our X and Y axis. We know from above that X represents rides, the number of rides we actually get on. And the Y-axis represents total money spent. Total money spent. Okay. Now, our graph, when we go back and look at it, we see, if it wants to come up, there we go. We see in this picture, if I hover over this point, we see 0, 5. That is our y-intercept. And literally what that point means is if I ride 0 rides, I pay $5 just to get into the fair. I'll show you something cool about our answer in just a moment that we just saw. So let's go back here and let's actually draw that in. So I'm going to put a point here. Again, we're just doing a sketch. It doesn't matter what the scale is, but I'm going to label that point as 0, 5. That tells me, it looks like a 6, but it's a 0. That point right there tells me, hey, 0, 5 represents my y-intercept. That's my initial value. I'm recognizing that that 5 in the equation is seen here in the graph at 0, 5. Now, another thing that's just kind of cool to help you understand how the equation, scenario, and graph are all represented together, I want to show you this. Let's look at this. If you go up to $20 on your, sorry about that, $20 on your y-axis, because that's how much money your parents gave you to spend, and you go over to the line and go down to the x-axis, notice how you get 30. Isn't that the answer we just got previously? That if I get $20 from my parents, I'm going to be able to ride 30 rides. We can literally see that in the graph. $20, since y is total cost, scroll over, down, 30 rides. For instance, if I had $10, I could ride 10 rides. If I had $12, I could ride, what would that be? 14 rides. It's kind of interesting how that works, is that anytime you want to find either, let's say 40 rides, or 40 rides, how much is that going to cost me? 40 rides, go up to my graph, go over, looks like it's going to cost me $25. So use the graph to kind of confirm your correctness on your problems. It's kind of helpful in that sense. All right, as we move forward, ask your neighbors if you have questions. You feel free to email me some questions. We are going to check this together on Tuesday, so it needs to be done by Tuesday. It's not going to be able to be finished in one day, so this is what you're working on as tomorrow as well. If you notice someone without a phone or anything to help them, be the student who invites them to come watch with you or work with you. All right, highlighters are in the back. Good luck, and email me if you have any questions. I'll see you Tuesday.